Our topic for today is load model development for mobile performance testing. Now, all of us on the phone may already be doing load model development for regular desktop testing. Why would we want to break out mobile? Well, we're going to go through and take a look at some items that are peculiar to mobile that might inspire you to look at mobile in a slightly different way. So let's go ahead and get started. First, a little bit about our organization. We've been engaged in the performance engineering field for various customers since the mid-1990s. LightSquare is our specialist measurement division associated with production monitoring and production analysis. And what separates us is our ability to measure specifically at the web server tier and treat that as if it's a database server, so we can profile the web tier, which is kind of a unique market offering in this case. Also unique about our market offering is that we do the work up front in our LightSquare practice, and unless you see a measurable improvement from our recommendations, you don't pay us anything. That's right, no risk. We do the work up front, no improvement, no payment. A little bit about my background. Some of you on the phone may know me, James Pulley. I am the chief geek of LightSquare, which means I'm associated with all the bits, the bytes, the services, the servers, anything that touches any piece of technology within the organization. My background includes being a host of Perf Bytes, who I believe one of our attendees is also a listener to Perf Bytes. Our organization and myself, we moderate a half a dozen forums on performance engineering topics. And over the last decade, I've answered over 10,000 questions online related to performance engineering and performance testing. And I've answered just as many offline for our particular customers. So that's 20,000 questions and answers of lore to build up off of the last decade. So why do we need a separate mobile profile? Well, our desktop users are pretty well established and their connection model is pretty well understood. However, our mobile users have some distinct characteristics associated with them. One, they have what's called a high latch time. And here's what that means to you and I, is that it takes longer for them to connect. When they use a resource, they hold on to it longer and they take longer to disconnect. Now, this is important because the client-server model is built around this concept of very chaotic use of a resource. I come, I use a resource, and I depart, and that time period between my use of resource is when other users come and use the system. If I have a longer latch time on a resource due to mobile or in the old days dial-up, that means I can get fewer users on the server, and I have to service that connection longer, and that takes a lot of CPU. Mobile users also have the longest communication path. That is, they are completely decoupled. They're out roaming around the earth. They connect to a mobile tower. They have the most error-prone connection as well. So you have this combination of longest connection, highest amount of error, and the longer latch time, and you get a very high service quotient required for these types of users. So a smaller number of mobile users can actually take down a server versus desktop. Now, there are also some mobile items which are driving this. I pulled a statistic from a site on the internet. I'll get you the details on where it came from later, is that 57% of users are using both mobile and desktop to communicate to servers. So you have this population, people that are exclusive desktop, people that are exclusive mobile, and this group in the middle which has both devices that they're using to access their common website. Now, this would be okay if both of them have the same user experience. The problem is you only have about a 10% conversion rate if you're looking at e-commerce sales for desktop, and you have about a third of that associated with mobile devices. So you have 10% that are actually going to add something to a cart and continue that process, and then you only have about 3% of those, that total population, on mobile. Why? Because it's the experience. Getting back to that issue of latch time, looking at how this is growing over the next year, right now, anywhere between 1/3 and 1/2 of your users are probably mobile on your site. You may or may not know this. It is growing precipitously. Apple, as an example, has about half their user population on their site is mobile. That means that they have to build specific farms just to service their mobile users in order not to impact their desktop users. Amazon, while as a whole they grew last year, their mobile user population grew 26% over that same period. So just mobile users grew 26%. So that's why we need to break them out in our load profiles, count for this growth, count for this higher latch time, and make sure that they're appropriate to what the actual users are engaging in. Now, how do we do that? So we're going to cover a number of topics today. The first of which is finding an objective data source. Now, that may seem easy. I just go to my operations person and they'll tell me what's going on. It's not that simple. There's some characteristics that you need to have in your objective data source in order to make it definitive. We're going to take a look at how you filter the data coming from that data source to look just for mobile information. We want to talk about why it's important to include the entire page. Finally, we want to take a look at capturing data in production, modeling impairment, which deals with this latch time issue that I mentioned earlier, and then kind of a preview of coming attractions. We have a bot seminar coming up in a couple of weeks, and we want to give you a preview of that and also discuss it because bots are resource thieves that impact mobile dramatically. So the objective data source, and let's talk about the difference between objective and subjective in this case. Objective means that any two people can look at the source and come away with the same data. Subjective means that I have to bring something to the table to the data source. So we need a data source which is comprehensive in nature, that includes all of our requests, and that even includes items which might be captured by our content delivery network. It might be captured by other portions of the enterprise, such as stopped at the firewall, but we want to see 100% of the requests. If you have a large distributed enterprise, particularly one that involves third-party integration with a content delivery network such as Akamai, this objective data source for 100% of the load is often not your web servers internally. So keep that in mind. It is often not your web servers internally. It is very often, perhaps, your CDN access log. It shows 100% of all the requests, including what was handled at the CDN tier and what was not. It might be third-party items, such as integrations with Omniture, WebTrends, companies such as SOSTA, which use a JavaScript add-in to actually capture the number of requests. But the deal is you want something which has 100%, is reference and authoritative. And as a tip here, before you decide which one is going to be authoritative, take an inventory of all your data sources that you have in your enterprise. That can be from your application servers, HTTP access layer. It can be from your web servers. It can be from your CDN tier. It can be from the marketing information that's being collected by companies such as Omniture, WebTrends, or SOSTA, and it can also be the CDN logs. But take an inventory and then go to each of these sources and get a representative sample to take a look to see which one will give you 100% of all of your requests. And that includes top-level page as well as the resources, such as images, JavaScript files, style sheets, things of that nature. Once you have your reference source, we're going to need to filter it down just for mobile. Now, what I've done in this case is I have an HTTP access log item here in white, and this is from my actual phone. going against lightsquare.com. And the reason why I did that is I wanted to show some particular characteristics which allow you to distill the information coming from your reference data source to something that is usable for building your load profile. So to start off with, we need a tool in order to cut this effort down very quickly. Internally, we use Splunk, and we also use Microsoft Log Parser. Sumo Logic is also another great item in the market, but you want something that's dedicated to processing logs, which allow you to make queries against the logs that have been collected and provide a distilled data set for your use. Item number one, you want to understand how many actual users are on your system. The unique IP address, in this case 75.181.80.114, provides a view of the number of unique connections. Now, if you're using a CDN, often this information will be passed inside of the user agent string as something called a true client IP address or something of that nature. So you'll want to watch out for that. And if it's not configured, go ahead and configure it. But this provides an objective way for you to look at your data source to determine how many users are on within your average session duration. So if your average user session is, say, 6 minutes, you can block this out by 6 minutes, and you can see how many users are on within that period of time so that you can accurately reproduce that number of users concurrently within your system. Now, one thing that is very nice about all of our mobile users is that all of the user agents actually include the mobile keyword. Whether it is a phone or a tablet, if it is configured to use a mobile interface, you will find the mobile keyword associated with the browser. And that allows us to pick out just those requests which are associated with mobile as opposed to desktop in this case. Once you have all of the mobile requests, the next thing you need to do is get just to the top level page, because we're not going to write a piece of test code which has every single component in it. We're going to say request the page and then have the page load all the resource components. So what you will want to do is filter out things such as style sheets, JavaScript files, images, any sort of text component, basically anything that would show up on a page. It might even include Flash components, etc. So essentially what you want is this top level request, which you see in green here, which is get seminars in this case, and any of the page components we're really not interested in for building the load profile. And then finally, this answers the question about how do people navigate through my system? And that's a real difficult challenge to address in most environments. We think we know, but we might not have it exact. The referrer field will tell people how you arrived at that page. Here it's in blue. You'll want to take a look at your log setups to find out which is the referrer field in your particular environment. But what this is telling us is that I arrived at the seminars page coming directly from the frequently asked questions page. Now, most people might think that I would have come from the home page directly to the seminars page as a common path, but in this case, I took something a little bit different. This allows you to build a tree of activity in the system. That is, I can see, for instance, people arrived at the seminars page, some of them arrived from the home page, some of them arrived from the frequently asked questions, and we had some which arrived from pricing. So when I start building my virtual user code, I can either make those decisions within the code or pick the most common path through the system if the other paths are not too distinct that would use different resources. Now, something to watch out for in this case. You will want to check the requests for unique pages, and here is the reason why. We always talk about business processes when we're going to test under load and performance, and typically these business processes have a leaf page, that is, a page at the end of the business process which is distinct for that business process. An example, I might have a page called Order Confirmation. The only way I hit that page is if someone checks out, goes through final payment, and then finally I get an order confirmation up which has an order ID. So if I were to inventory those number of unique pages within a particular period of time, say blocked out by my 6-minute session duration, I could tell you for those unique business processes how many times that occurs within a particular window. So that's very important. Remark those unique pages and tie them to specific business processes, because that will help you build your load profile of 1,500 checkouts every hour or every minute or every 2 minutes, that you can provide an objective validation of this from a mobile perspective. Now, this next one may seem a little bit counterintuitive. It's very common these days not to load all of the resources in a test. Now, that might seem odd when you think about it, but there seems to be a common understanding or a common feeling within a lot of the load testing community that, oh, we don't have to load static resources, we don't have to load images, we don't have to load JavaScript files, style sheets, and things of that nature, because that's all being handled by the content delivery network. Well, there's a problem with that assumption. Wherever we have gone in the last 2 decades where there's a CDN or caching that is supposed to be in place, about 95% of the time we find that that's misconfigured. And that leads to a lot of assumptions in your test design where if you're not including static resources in your test design, you're going to miss those errors. And those errors directly impact performance, especially for mobile clients. Because mobile clients, remember, have to take that longest path all the way from the most distant and error-prone location coming all the way back to the server. And how dramatically does it impact it? Well, if it can't be served at the CDN and it has to come back to the origin servers, or even if it's a missing resource such as a 404, you might double or triple the amount of time required to actually service that particular component to the user and delay their page loading time. So this helps to address one of those core questions of why your mobile users only convert on add to cart about 1/3 as often as you have on desktop, is because their end user experience is so much poorer. That is, it's slower, it's decoupled, and if it has to come all the way back to the origin servers because of bad design or something that wasn't caught, then they're going to abandon the page earlier and as a result not convert. So this specifically, be wary of not loading all resources. And if you have testing in development as part of Agile, such as performance unit testing, this is especially common. And your developers will make the argument that, hey, we don't need to load those because those are going to be handled by the CDN. Well, how about taking a page out of manufacturing in this case? Manufacturing quality control, Six Sigma, it goes by a number of different names, the Deming method. Let's employ some statistical sampling during our testing. So if we have 1,000 users and for 900 we're not going to load the static resources, how about let's do for 100, load some static resources just to see what happens. What do we see in the logs? What kind of errors do we see? Does it make a difference? And if it does, that means that you're going to be misconfigured either at your code tier, if you're adding headers dynamically, at your web tier, if you have configurations in your web server associated with caching, or potentially at your CDN, if you have CDN-specific settings and you're not respecting your origin server settings. Data in production. we always need an objective way to look at our test results versus what we see in production. Now, it is unfortunately very common that you run into a situation of, hey, we're seeing something in prod that we never saw in test. Why? Well, probably because you didn't have an objective method of when you were building your test, and then you didn't have an objective method for taking a look at your test results and then tying them back to production. In this case, you want to be able to take live comparisons for common business processes. You want to use things such as login. You want to use items such as looking at account information. If you're looking at a build-to-build change, if you have pages which are not changing on the build, you should be able to validate from your test environment to prod on an objective basis what is happening and if you're seeing common response times. Using your test tool might not be the best way to do that. And the reason why is that the people who are looking at the live website, if you're comparing page to page, their stopwatch may be slightly different than what's being used by your test tool. So in this case, what you'll want to do is leverage a specific feature of your web server, and it's in every web server, every app server. It's the W3C time taken field. So if you'll adjust your log settings, you'll be able to go ahead and take a look at login on a W3C basis and then match that up to login and prod. So you get a nice objective validation point. Modeling impairment. Because of this long latch time and this high error rate, if you do test at wire speed, if you test it at Ethernet speeds, you are not going to get a solid view of both how much resources are being used by the client and what the client's response time is going to be. So you've got these two items. One, is the client fast enough and performant enough? And two, is it using the same amount of resources on my server as it will use in production? This is where impairment comes into play. Now, impairment is going to be either via software or via hardware. You may have heard such tools mentioned in the market, such as WANM on the open source side, or Shunra on the commercial side, which is now a part of Hewlett-Packard. And there are a couple of other tools in the market as well, both hardware and software based. But the trick is you need to make sure that your item is matched up, your impairment is matched up with observable data from production. How do you get that? One, you can get it from a third-party service like Ookla, which is the company behind speedtest.net, which just about every support organization will tell you, hey, let's go to speedtest.net and run your speed if you ever call in for a performance issue to a cable or DSL provider. They collect that data live all across the world, so you can actually do impairment models from other countries, from rush hour involving mobile devices, from Chicago in the morning, things of this nature. It is critical that you get an accurate model. You can do ping tests and get somewhat accurate models, but it's not going to give you the actual error rate, which will require retransmits that you can get from Ookla. You also want to validate your impairment and what you're seeing in production with the W3C time taken field back to prod with test. If they're not matching up, if you can't look at a login on mobile and prod and a login in your test environment and see pretty close to identical response times, you've got an issue that needs to be addressed on impairment. Now, this is not an easy problem to address because you need to be able to provide an impairment model either on groups of users who are clustered around a tower for mobile or on an individual basis. And this leads to this recommendation of you need to be taking a look at something which is integrated with your test tool. Now, there are a couple of test tools out on the market which have integrated impairment. probably the dominant player in the market with integrated impairment is the HP product line. It's LoadRunner, it's Performance Center, it's StormRunner in the cloud. You also have third-party services such as SOSTA, which does have an impairment model that you can take advantage of. But the trick is, because you need to impair almost at the individual connection level, you need to have this integrated with your test tool. So you can potentially validate that a client that looks like they're in New York City in your production logs also matches a client that appears in New York City from your test logs in this case. Very, very critical for modeling impairment, once again, to make sure that you get accurate response times on the client and that you're using resources in the same way on your servers. Finally, we've got a preview of coming attractions. Now, why would I bring bots in this case? Bots are resource thieves, and mobile devices are very critical and also in use of resources. So as you have bots stealing resources, the users that are going to be most impacted are going to be your mobile users because they have the highest latch time and the highest use of those items which are disappearing. So what is the easy process for finding a bot in your environment? Well, step one is take a look at those hosts from your access logs and count the number of requests. Now, in this case, you will want to look at your origin servers. You may not want to look at your CDN, although you could use your CDN, but third-party services such as Omniture and WebTrends and SOSTA, you're not going to get data for bots out of these environments because bots typically don't execute the JavaScript that's required in order to be able to push results data to those third-party services. So go to your CDN, go to your origin servers, and do a count of the number of requests by each IP address in a 24-hour period. You will find that those that are commanded by automated agents stick out very, very quickly. The number of requests that they make are head and shoulders above everyone else, and they typically do so in a manner which is not human-based. That is, they will be executing them faster than a human, such as once every 500 milliseconds or second and a half or 2 seconds, something that is almost unheard of, essentially like no think time in a test. And their error rate will be higher, particularly if they're doing traversals of your site just looking for pages. So I'm looking at page 1, then I'm looking at page 2, page 3, page 4, page 5. Both on a frequency basis, I'll be doing that very fast, and I'll be generating a lot of errors. So what you want to do is use this information about frequency and error rate to tailor a firewall rule to randomly deny these people for a period of time, or these agents for a period of time. And it's important not to block them altogether. This is more of a psychological issue with the bot owner. If they're getting through only a portion of the time, say they get 5 requests through and then they're denied for about 15 minutes, they might actually assume that the site is under load and nothing is wrong with their bot. So you extend the useful life of your firewall rule in this case. But eventually, the bots will evolve. They'll try and figure out a way around your firewall rule, and you will need to retailor the rules. So make this a periodic investment of time. Once per week, month, quarter, once a day is probably a little much unless you can automate this process. But the idea is here you want to find the resource thieves that are tackling the resources most scarce for your mobile users, get rid of them, and hopefully you'll recover a resource pool that can then be used to your mobile users. This brings us back to our organization. LightSquare, once again, is our measurement division, more for production than it is for test, although we do testing as well. And our unique proposition in the market is that we do the work up front, no improvement, no payment, and your payment is directly related to how much improvement you get. So if you have any questions, take a look at www.lightsquare.com, or you can mail us at info@lightsquare.